Um, Tonight is an introduction. We are focused tonight on making sure you have an overview of all of the items we will discuss during the class and give you the opportunity to study in advance prior to the class so there can be maximum questions and maximum conversation about the topic of the moment. Next week we're going to focus heavily on computer-assisted design. We're going to focus on the Vectric software for that session. And next week we'll also do a walkthrough of the wood shop. A walkthrough where we can focus on safety topics or the tools that you will need to use to build a box during the class. Wes?
I have a question. On the next week's session, is it going to be limited to 2 hours? 4 to 6?
We'll have I had planned an hour in the wood shop and an hour here in this room.
The only reason is at 7 o'clock, there's a big thing in the auditorium.
Okay.
So if you can still attend class and make your function if you want to go to it.
Okay, understood. Yeah. We will make certain, or she will probably make certain.
Joe, is Vectric the singular? Is Vectric like Kleenex and Formica? Or
Vectric is a corporation, and it is with multiple products. They are based in London, and they are the gold standard for woodworking in the industry. Now, did that answer your question, Jeff?
they have competition, but it's not to their level.
In the dust. I'm serious.
Does it run on Apple? Because I couldn't get it installed.
The software will only run on Microsoft PCs.
Oh, well, they're not up to date.
There's been a lot of discussion on that topic, but that's really where the market is for the company.
Okay, so
Let's see, the other 5 classes are listed here. We're going to dedicate a night to discuss how to go about creating tool paths for a given object that you're trying to cut, whether it be a decoration or a pocket somewhere on your piece of work, or maybe just cut a profile so that you're cutting a component out. We will discuss that thoroughly on the 3rd night of class, and that's the night that we will do demonstrations on the machine. We'll go out and we will cover enough that evening for you to understand the concepts of running the machine, and then there'll be homework assignments that focus on the controls of the machine. Vectric software, advanced CAD and CAM tools, the 4th night. The 5th night we're going to switch away from woodworking and focus for that 2 hours on our 3-dimensional printer. We brought it into the wood shop a couple of years ago, and we found it very handy for creating minor tools. And we'll talk to that in detail on the 5th night of class. And then on the 6th night of class, we're going to switch back into woodworking. The Vectric software is primarily a 2-dimensional design software. And when I say 2-dimensional, does everyone understand? I'll touch on it several times tonight. But the software does have the capability of managing tool paths for 3-dimensional carving. The 3-dimensional discussion for Vectric will occur on the evening on the 6th night of class. And then we'll wrap up on the 7th night. We'll focus on actually assembling a small box. That's the night where should there be excess questions, that have not been answered. It will focus on any lingering discussions that you might have. So that's an overview of what we're going to study over the next, on tonight and the next 6 weeks. The class environment is really pretty straightforward. We will use this room for tutorials. Here is where we will preview a concept. And then we will use homework assignments to give you professional presentations on that particular concept beginning that evening. The goal is to use our class time to get a high look at a particular topic, a particular concept, and then bring the details in with your homework study. I mentioned practical demonstrations in the wood shop. We'll do several during the class. Also, every afternoon I hope to be in the wood shop. So if there is any topic that you're having difficulty with, we'll have that time for one-on-one conversations. Just stop in the wood shop or in some way make an appointment and I'll make sure to be here. Okay, the class material is also pretty straightforward. Each of you by now have received an email having to do with the website joesboat.org and the library that's available there. I will preload presentation material. And by the way, preload means that for a 4 o'clock class, I'll get it there by about 3, the final copy. Anything prior to that 3 o'clock release might have some issues with it. So don't hesitate though to consult the website and think in advance about what we're going to cover in a particular session.
I do have a question on your Joe's Boat. I went to there and I couldn't log on. It asked to log on.
It does give you the opportunity, but in the public domain, there are 2 libraries there. One that's dedicated, and I'll talk more about this later. One of them is dedicated to manuals on the CNC equipment that we have, and the other one is dedicated to class information.
Okay, so you don't have to log in.
You do not have to log in.
Okay.
Now, there will be a login for every member of the class. And inside of the login, there are many copies of Vectric files, of boxes that I've cut over the years. And they're there for your reference. And if you want to bring down a box that's not directly in the class path, you're welcome to. Okay, joesboat.org. There's also, as you go into the wood shop on the left-hand side of the door, a rather nice woodworking library.
Okay.
There's textbooks on many woodworking topics that you're welcome to bring out, read, borrow, return as appropriate. And the biggest library of all, and it's really unlimited, and that's the internet itself. Okay, we make extensive use of videos from the internet in the homework assignments. Okay. Well, class goals, pretty straightforward. Number 1 is be safe. And there's going to be a lot of conversations about safe use of tools next week. As I mentioned earlier, we will cover each of the machine tools that we think you will need to use in order to build the class project. And I will talk to the class project later on this evening. I want confidence. I'm assuming that this is going to be just the first box. This is going to be the prototype that you guys will create. And you'll develop the skills here to plan for future projects. And that's really where we will emphasize at several points during the class. Skills, of course, and by far, let's enjoy these sessions. This is our opportunity to sit down and talk about woodworking, our goals, what we've done. Let's have a good time during the 7 sessions. Any questions before we get started? Paul?
Do we need to bring our computers in, or do you have a shop computer that will be able to bring in our plans and something like that?
I'll speak to that in detail tonight and as a part of the makerspace conversations. Okay. Looking around, any? All right, session number 1. 5 topics tonight, pretty straightforward. The first topic, I want to provide some examples of 2-dimensional and 3-dimensional computer-aided design tools. Just a high-level look at what the tools are capable of. And in your future study, I think each of us here will have the capability of doing design work like I'll demonstrate tonight. We're going to do an overview of CNC and go a little bit deeper than the 2 main computer-assisted design and computer-assisted manufacture. We'll go a little bit deeper than that tonight, and during the course, of course, we'll get very deep over our heads in some instances. I'm going to cover the tools that we have available to us tonight. I'm going to talk about the class project and the resources that each of us will start with in order to prepare to build a box, and then the steps of doing the build. And then I'm going to jump into the Vectric VCarve Pro software and do an overview of that piece of software at a high level before the homework tonight. We'll get into many of the details. Okay, so that's tonight. Wow. Chris, you might remember some of this from the very first class a couple of years back.
I was over this earlier.
We think about any project, we think about it from the conceptual point of view, maybe a back of the envelope drawing that we're eventually going to refine to where it will make sense to somebody beside the person that drew it. Then we're going to plan how we're going to build it. And then we're going to have to plan on how we're actually going to create the parts and assemble it. That's the process that we are beginning as we think about 2-dimensional and 3-dimensional design tools. Let's start with 3D. Let's switch over to a different tool. Here is an approximation of the box we will build during the class. It's a 3-dimensional design, and a box has 6 sides, so there is 6 components that's been drawn here for this design. I'll just start by taking the lid off the box to show some detail as to what's available in the box. If I look at this left-hand box side, you will see a mortise, a U, cut into the left box end, and you'll see a front and a back, here being a front and a back that's a tenon into that mortise, okay? And if I take away the one of the sides, and let's take away the right side, and I reorient the box, you can see the structure. And obviously I can take away the front and the back. And now you have a clear view of the mortise that's in that end. Now here, I've used this software to draw 6 components, tell the software how they fit together. So the software understands all of the dimensions of the box that we will eventually build. Doesn't really directly tell us, but if I switch over to a product created from that design by this software, you can see the straightforward. We've all had mechanical drawing, right? Okay. So we see how we can represent, in this instance, 5 of those 6 parts, and give us the dimensions. And I've chosen to not bother with the 6. That's the box bottom. We just go manually create that and plug it in at some point. So that's the capability of what a 3-dimensional drawing package can capture about a particular design. It can organize each component, giving me the source drawing for that component and the final piece of wood for that component, or the simulated piece of wood, I should say. So that is the 3D drawing package. Now, the products of this particular software have the capability of driving a router, a lathe, maybe the 3D printer. But it turns out that we have a disconnect between the products that this software outputs and our computer control router. So we can use this tool for design work to put together a 3-dimensional design, but I can't at this moment, and that might change in the future, at this moment I can't take this software, convert it into a file, insert it into the computer control router, and cut these 5 parts. That's in the distant future. Chris?
This is Fusion, correct?
Pardon? Fusion.
Yeah, okay.
Yeah, I'm going to speak more to this particular piece of software later on. It is available to us to use for the 3D printer. And in session 5, when we talk in detail about using the 3D printer, we'll come back to this software. The most useful piece of software we have is Vectric. And if I switch over to the Vectric product, here it is, we can draw in 2-dimensional format in the Vectric product. And then the Vectric product, through the creation of tool paths, can convert that 2-dimensional drawing into the 3-dimensional object, the 3-dimensional part for the box. If I look at the drawing, here of course is the box top, and I've touched that outline just to show that once it's highlighted, I can touch it a second time, and then I can move that box where I want it, or that rectangle where I want it, and then of course bring it back to where I need it to be on the workpiece. This would be the box front, the box back. This would be one of the sides, either left or right. They're symmetrical. If I turn it over, I see that on the back I could also draw, and maybe this would be the opportune time to think about looking at a decoration that's going to be on the end. And let me turn that. There it is. Turn the decorations for the end of the box on, and if I turn it back over again, you can see the decorations for the top and the front of the box. Okay. Before the night's over with, we'll go into a lot more detail about this drawing. Okay. Okay, I've talked about the 3D, and I've talked about using the Vectrix tool to draw in 2 dimensions. But once those drawings are done, I started 4 years ago saying that the artist and designer does the drawing, and that quite often that's the case. Quite often it's the same guy that's going to eventually put the plan together to do to cut the components. So the engineer comes along, and he has to identify how to put the materials together to do the cutting by the CNC component tool. And he then comes along and he creates the CAM tools to create the components. And let's see if the switchover works this time. If I switch over to a 3-dimensional view and I switch into a piece of the software that I'm able to use to the engineer is able to create the tool paths that's going to follow those individual lines to create the components with some decoration. And if I go into a tool that will simulate what the capability is, that is one side that, and if I flip it over and do the same thing, that's the other side. And of course, that in fact created this particular box, and I'll let you start to pass it around.
To create the design, did it cut out the...
That's something close to the design.
Okay.
Close. And I'll start this one here. This is a slightly different design, but you pass that one around. Not quite as finished, of course, but I think I accidentally showed that particular design. It's also the... So after the engineer has created the tool paths, the process would be to pass it over to a technician who would be focused at getting the raw materials needed to do the cut. He would be focused at loading the machine with the software needed to control the cut, and then execute the machine and clean up afterwards, sanding, whatever fine-tuning of the cuts is needed, assembling the box, and then, of course, doing some finishing. And that's the process that we will follow as we go through the 6 nights. Okay. Now that particular box is not glued together, so the ends might pop off as you pass it around. Whatever the issue is with the transitions between the various software products, that'll be fixed by next week, for sure. That's a surprise tonight. All of the practice sessions, everything works perfect when you're practicing. Step by step. That's a prototype. Okay. That box was cut from what I call a CNC blank. And those of you who've been in the shop, I've pointed them out before. And that's really the manual woodworking task that you will have in the class, is to take a raw piece of wood, reduce it to the number of pieces you need to glue together. Okay, this happens to be wood for a 3/8 inch box. But so the manual task during the class will be to take the raw wood, reduce it to the size box that you want to create, glue them together into the CNC blank, and then we'll take that into the CNC machine to cut the 5 components. That would be the top, the front, the back, the left and the right side.
Puts the design on it?
Pardon?
Does it cut the wood or just?
In one step.
In one step?
The wood, once the blank is loaded, the CNC will go through a series of steps to do everything.
Off your dimensions and stuff that you've created on this?
On the soft file. Okay. Yeah, that.
Do you want to take questions as we go, or?
Sure, let's go.
It looks like avoided having the glue joint show up on the sides or the top. And that's simply by casting those, or was that by predetermining where the glue joints were?
The art, you're addressing the design of the wood or the grain pattern of the wood as to where you want the cuts to occur,
Right.
and to where you want the design to occur. That's where you're getting into the art of what we'll want to do. Sometimes I'll go and find the most bland piece of maple I can find, so I don't have to make those decisions. I just have to make the decision as to whether I put it in horizontally or vertically. A lot of people make money by just getting that grain pattern perfect, where you're going to see from the front to the side to the back to the next side one constant grain pattern going around the box. Very, very time consuming, and it can be done. Let's see, did I misunderstand the question?
I don't think so.
Okay, all right. And the technician then has the final assembly task, the finishing of the box. Let's begin to talk about the CNC terms and concepts. I'll use the abbreviations quite often. If I come up and use an abbreviation and I have not explained that particular term, throw a pencil or a piece of chalk and please. I've talked about the CNC. It's both the CNC process and the CNC file that would be brought into the computer into the machine to cut. Like I say, CNC, computer numerical control, it's an umbrella term used throughout the world. And then within the umbrella, one of the detailed terms is also CNC. Here we're referring to the file. Quite often it's what we call a G-code file that has the detailed steps that the machine will take to do all of the cuts. Okay? You might say it's the detailed steps of a given tool path that's contained within the G-code file. The computer-assisted design, the tools I've demonstrated, they're the tools that we use to tell the computer about the design. I'd love to say draw the design, but it's really a little bit more than that. You're drawing it and then you're giving the computer some information about that design. And then the manufacturing, here's where we get into the tool paths. The tools to convert a design into the series of machine actions. More details. You see a line on a drawing. To a kid, that's a line. To the CNC and the CAD world, that's a vector. A vector can be a straight line, a square, a rectangle, a star, a circle. Okay? They're all vectors. And a vector to the computer has knowledge of what the object is. It is a circle. It knows what the radius of that circle is, and thus it knows the diameter. Okay? Same for a piece of line. The computer knows the three-dimensional starting point of a line and the three-dimensional ending point of a line. And thus the computer knows that he could make a cut between those 2 points to do that cut, for that component. Raster image. Everyone here, we're looking at a raster image right now. This is nothing but a picture of something. Here it happens to be a picture of a presentation. The absolutely no knowledge in that raster image as to what that information is all about, what that data is all about. I mention it because quite often you're going to want to convert a picture into a design, and there is a process to do that, but it's a process that you have to understand and follow. I mentioned G-code already, stepping to the bottom of the list. G-code is an ANSI specification and an international specification. There are parts of the specification that are fixed, that's universal between almost all machines. And then there's a portion of the G-code specification that can be unique to a machine, and that's well known throughout the industry. There has to be the machine designer has to have some ability to do unique things that only that machine can do. And stepping backwards to toolpath, the toolpath is the set of steps that the machine will take to move, in our case, a cutting edge from one point to another point. And that might be one broad stroke if it's a simple line. And if it's a circle, that might be thousands of individual little steps for him to go around the circumference of that circle. Getting away from terms of the CNC terms, VCarve Pro Makerspace Edition is the software that we use, and we will use in the first 4 sessions of this class. It is a product from Vetric Corporation. I said it's a gold standard of the industry. The second product is Fusion 3D. Have anybody ever heard of AutoCAD? Mm-hmm. Okay. AutoCAD has been the gold standard in the design world. It's got a few years left there. But Fusion is a new product from the company that makes AutoCAD. The name of that company is Autodesk. Autodesk makes AutoCAD, and now they're making Fusion 3D. It is free to hobbyists, but to any company that wants to use it, they pay big bucks. Like, I think the minimum is probably $350, $400 a year, and then it goes up from there. And then the other two terms, the CNC router that we own is from NextWave Corporation. That's in Ohio. We have the Shark HD510 model from NextWave Corporation. And then our 3D printer is a Creality Ender 3. It's another often used 3D printer throughout the world. And it's there'll be probably more videos on the Creality Ender 3 on YouTube than any other 3D printer. It's a well-known, very well-known. In addition to the two tools that we will use, I did want to mention some other tools just to get a perspective of the industry. You guys probably are very aware of Adobe Photoshop and probably Corel Draw and Adobe Illustrator. Okay. The Corel Draw and Adobe Illustrator are vector design tools, where Adobe Photoshop is a raster design tool. If you have experience with Corel Draw or either Adobe Illustrator, the Vectric VCarve program is going to be really easy to use. It's just a natural moving from those two pieces of software to the Vectric product. Of course, in CAD systems, I mentioned AutoCAD. There's a couple of others. In 3D CAD systems, there's AutoCAD, TurboCAD, and FreeCAD. And of course, the ones we are using are Vectric and Fusion. I mentioned two that are free to download and rather respectable tools, pretty good. One called GIMP that's sort of modeled after Adobe Photoshop. And then one called Inkscape. Inkscape is, again, a free download. It's a vector design tool, and it can export files in all of the common 2D and 3D file formats. What have I not said about Vectric Desktop? I mentioned it's available only on Microsoft. It is a 2D CAD and CAM system, and it has some three-dimensional carving capabilities. And we will cover the 3D capabilities on night 6 of the class. It is the woodworking standard, the gold standard for woodworkers. I'll talk to the Makerspace edition a little bit later. Fusion 3D, I say, is an evolving professional product for many industries. I'm guessing that 10, 20 years from now, that might be the gold standard in the architectural and other worlds. It is headed that direction already. It's available for Microsoft, Apple, and Unix computers. It's free for hobbyists. Okay. You have to, when you download the product, you'll have to certify that you'll not use it for commercial purposes. Pretty straightforward. I've talked about product, primarily the two that we're going to study, Vectric and Fusion. A little bit of information about the file formats that are either used by these tools or generated by these tools. If I go up into the image file world for raster files, we've got BMP, GIP, TIF, PNG. They all store raster image. They just store it in different formats. Just different formats. For two-dimensional files, we've got DXF, DWG, that's the AutoCAD standard. DXF is the exchange format for two-dimensional and now three-dimensional data. For 3D models like Fusion 3D, there is an F3D standard. It's the Fusion archive format. And then there's the STL. And STL is the common file format that's used to pass information from a CAD package to a 3D printer, STL. And back to the Vectric, the CRV file format is that's the format that the Vectric vCarve software will save information to. Down at the bottom for G-code, like I said, it's an ANSI and an ISO standard. It's the set of steps that's going to control the movement of the cutting head in a router. And we'll create tap files in Vectric vCarve for our HD510, and we'll create G-code files out of, well, I'll get into the 3D details on night 5, but we will eventually create a G-code suffix file to enter information into the 3D printer. It's 5 minutes to 5. Maybe we could take, let's take 5 minutes and relax for a little bit. Let me get a sip of water, and we'll return at 5 o'clock. Restroom is right down the hall. Okay, welcome back. Welcome back. We are. I've mentioned Makerspace several times. Has everyone here received the emails that I initiated from Vectric Corporation?
Yeah.
Okay. Who has not? Okay. Then I'll follow up on that.
I don't recall seeing it.
Then let me make sure. I'll make sure you're on the list also.
Joe, I got the email and I clicked on the link, but it didn't accept my username and password.
That could be because it was already set up for you, Alan, from a prior class. That could be.
So
Let me.
Okay.
I'll follow up. I got 3 follow-ups.
Okay. I wondered about that, but anyway.
Okay.
Yeah. Thank you.
I've talked about the Vectric vCarve product up until now. When I had information about vCarve on the screen, one of the bullet points said that when we purchased our Shark HD510 system, with that purchase we received a copy of vCarve Desktop, which is a cripple version of the vCarve Pro software. Okay, and that license is for one person or one use at any given point in time. So that software, while it's good software and it's very useful, really wouldn't serve a community like these classes. And it was recognized within the club that we needed to make a purchase that would give us multiple, allow multiple members to use the software at the same time. It turns out Vetric is very involved in supporting school systems, and we found we were very pleasant. We were very happy when we found that they supported nonprofits like our club. And so we have a license with Vetric, what's called a makerspace license, that gives us access to the good VCarve software, the VCarve Pro software, in a client-server environment. You, the students, are the clients, and the downloaded copy of the software that you get from Vetric by itself allows you to go in and study the software, create designs, create toolpaths. It allows you to do everything except move a tool path to a file that could be used by a CNC machine. Okay? That's how they control the demonstration software and allow people to study it but not profit from it. The Makerspace license comes along and it closes that gap. Now you can do everything that you could before with the VCarve Pro software. You can create the tool paths, and after you've logged into Vetric to identify yourself as a member of our makerspace, it allows you to save the file. But the file saved is only useful by it could be used by other clients in our makerspace, but it's only really useful when it's inserted into the VCarve Pro Master or the Makerspace Master that we have in a laptop PC that exists in the CNC cabinet. Okay. And Vetric controls the transfer of files with an internet double check each step of the way. They sell some very elegant, expensive software. A simple license of VCarve Pro is right at $800, $1,000 in that range. Their three-dimensional design software, different name, is called Vetric Aspire, A-S-P-I-R-E. It sells in the 2K range, and that's for one version of the software. When you go to a new version of their software, there's an upcharge if you want to go into the new version. Now, the Makerspace handles all of those upcharges for us, all built into the Makerspace license. They keep us with the latest version of their software right now, which happens to be version 12. And it is a refurbishment of the user interface between their version 11 and their version 12. So for Chris and Wes, who've used the software before, they're going to be interested in the differences in the way the software looks. And there are some minor and maybe major new features in the software that weren't available in the versions that we studied a couple of years ago.
So, excuse me, so we're paying an annual fee to Vetric?
We pay an annual fee to Vetric Corporation, and it's not expensive, it's $100 a year, which gives us the ability for 5 of our members to simultaneously use the client software. Okay? Now, as we step forward in this class, it is feasible that 5 of you are going to want to use the software at the same time. It's going to happen. We're assessing the situation. Is 5 copies adequate? Do we really need 5 additional copies? Maybe by the end of the class we can come to a conclusion there. For right now, we'll start with the 5 copies, okay? So each of you, in order to use the makerspace, will have to have a Vectric account. No charge, easy process to get a client. And then after you download, and oh, by the way, the homework assignment tonight is to download that software. Okay. After you download the software, on each time you want to use it, from the software itself, there's a login in the upper right-hand side of the window that you'll use to enter your user ID and password to Vectric. And that will, for that session, make you a member of our makerspace. And the files you save can be loaded into the master that's out in the wood shop.
So right now, 5 of us sitting in our apartments can log in simultaneously. And if the 6th person tries, it will just be...
Well, we have not, I'm speaking theoretically. We have not encountered the situation yet. Theoretically, you'll be told you have to wait for somebody else. Wes?
Yeah. Make sure you log off the system when you're done using it. Don't leave it on your computer in a rest state if you're locking somebody else out.
That happens to be in writing to Paul. Tom?
Does that mean you need to be connected to the internet anytime you want to use it?
That's correct. Yeah.
So, by the
Chris?
way, I would recommend if anybody does try to log in and they are told you have to wait, bring that information to Joe at the next class.
Sure.
And the time.
Yeah.
And
Yeah.
time-
Make a screen dump or something.
Because otherwise, we're not gonna know whether we need to go from a 5-user license to a 10-user
Yeah.
license or whatever, until you tell us what's going on. So
Now-
it's gonna be critical.
Now, there's a lot of truth in what Chris has said, but there's a piece of knowledge that we don't know right now. We don't even know whether Vectric is interested in selling us another 5 licenses. We might be stuck with 5, so keep that in mind.
When you create this account, it brings up a video file that's like 25 minutes long.
That's a part of your homework tonight.
Okay. It's an hour.
23
There's-
34 minutes.
There'll be about 2 hours of, maybe, it might total 2 hours tonight of homework
Tomorrow morning,
for this week.
5 o'clock this morning.
But you have 7 days to invest that 2 hours. Pardon?
Do the videos work on the Apple?
Oh, absolutely. Yeah. Yeah. All of,
Because I started watching.
Vectric, like all corporations, their videos end up on YouTube. They want YouTube to pay for the space.
Well, I was able to create an account, I just couldn't use it.
Okay.
Maybe you could go
You
through-
tried here?
Yeah, I followed your notes, but I mean,
Okay.
just
Maybe
made
you
it
go
like,
through the homework assignment at the end. Go through the homework assignment?
Yes.
Because when I read through it, I was thinking we only had the first 3 to watch. I didn't,
You didn't look at the optional homework?
I scanned. I scanned and thought, oh, that's for rainy day.
Let's see.
If I know I have to do it, I'll do it.
Let's see if I've missed anything here. Okay. Yes, you must log out from Vectric.com when you close your trial edition. It turns out that the software will ask you if you want to log out. We ask that you answer that yes. Let's see. That is Makerspace. By now you've all had the opportunity to go to joesboat.org. There are 3 libraries, and let me...
Where's your sign on?
Pardon?
Do your sign on to that.
Well, I have it up here.
Again, I can't transfer over to a different piece of software. I can do it manually though. My website, the library in the public domain first has a catalog of manuals. Pardon?
Are we supposed to be seeing it?
Yeah.
Can you hit escape? Will escape get you on that?
The library of documentation about the CNC products we have online. We have information here for the Shark CNC, for the Fusion 360. We have information on Vectric, and then a lot of miscellaneous manuals on the CNC technology from other manufacturers. That's in the, what I'm showing here is the CNC file library. The class library is right below it, LWVA CNC training. And for our class, there's a folder here that will store the presentation material. It will store it in PowerPoint and PDF format. Okay. It will, there's a folder here storing the homework information, and this is all in PDF format. Okay. Any computer can open a PDF file. And then last is the CNC project files. And I have them divided into the medium Paradise box, and that is the medium Paradise box. And I have it a separate folder showing the anniversary box. The anniversary box will be a session 6 topic when we talk about 3-dimensional designs as a part of the project. The medium Paradise box, I have it in a couple of different flavors. I have one with a side miter. The unfinished one here has a side miter on the top. Now, I said miter, meant to say mortise, a side mortise on the top. There's a 5-inch box that does not have that side mortise on the top. And this is the one I recommend that everybody cut for their first project. This would be in a 1/2 an inch thick material in that box size. And then I have a file for a 3/8 inch thick version of the medium Paradise box. That's the one that I'm in the process of creating using the slats that I passed around earlier. So these are all downloaded from the site. My particular PC here is set to download to, the downloads folder. It turns out that the PC I have in the wood shop, the master PC, it's going to download and immediately bring up Vectric for that particular file. So just, be aware that when you download it at home, it's going to go more than likely to your downloads folder, and then you can open it with the Vectric software. In the wood shop, it's going to open directly. Okay. Let's see. Later on, I am going to do a download and get into a demonstration to continue. That's an overview of the material from the website. I got to back up for a second. I mentioned earlier that I have set up a account on joesboat.org for each person here. And I've arbitrarily created the username of your email address and the password of your email address. So there's a tool, once you log in, you can make the account private for you, change the password to whatever you'd like. Let me just show that show that information. I'm going to go home. I'm going to log in as Joe, wherever Joe is. Here it is. And that's just going to add a folder to the library. It's called Joe's CNC Files. And you'll find here the name of the projects that I've done over the past years. There's, it's a variety. Mostly they are boxes similar to the project box tonight. There's also some files for a little 5 and 10 drawer cabinet that I created using the CNC. And you're going to find some 3D print projects also here in this folder. You're welcome to come in and experiment, download, and take a look at whatever, whatever's there. So yeah, that's the result of you logging in. Okay, back out.
Okay, go to the login again.
Pardon?
I'm confused on the password.
The login for your site?
This is a login to Joe's Boat, and it's your email address is the username, and the email address is the password.
Oh, okay.
Okay.
Does he want to see his password?
Yeah. Okay. This is a PowerPoint slide that says what I makes the points that I made when we were looking directly at the site. For the class project, I recommend that you do not use the one with the side miter, with side mortise. You can cut it either in the 0.5 inch thick material or in the 0.375 inch material. Now, we'll talk a little bit more about material later on, but while it's in my mind, the Woodcrafters, that's the store directly across the street from Costco. Most of the material they sell is in the full 5/4 inch format, 1 inch thick format. And right now they have a sale on spalted maple, that's that wood, for $4.33 a board foot. Good price right now for that material. The poplar is closer to $5 a square foot, and ash is also closer to $5 a square foot. Did you pick up material this weekend, Paul?
I did, I got salted, and I got it from Rockland.
Oh, okay.
They had they got a lot of wood.
The price similar?
It was, yeah.
Okay.
Are you remanufacturing the 5/4 into 1/2 inch product?
I'm into 1/2 inch product that then ends up to be 3/8 inch product. Okay.
By the time it gets planed
By the
down.
time you plane it down, it's practical, very practical to get 3/8, 2 boxes out of 1 piece of wood. Okay. As you look back,
Let me follow up.
good.
In remanufacturing a 5/4 board into 3/8 finished board, that's not done with this, that's simply a wood shop project.
Resaw?
That's a resaw.
Yeah,
Okay.
okay.
I recently changed the blades on the bandsaw. It has a very good 1-inch blade on it right now, and I did successfully do some resawing.
Oh, so
With-
you're cutting the 5/4 into 2 boards?
Exactly.
Huh, and
Yeah.
then planing that.
Yeah. For those of you who are experienced using a bandsaw, please be delicate with ours. And if you need it to be fine-tuned, I'll volunteer to come in and help if there's an issue there. I found it in disarray this weekend, big time.
Is there a fence for the bandsaw?
We do have a small fence. We need to talk about a nice 8 or 10-inch fence.
You had her buy thinner wood.
Yeah, we're not going to get to Vetric tonight. We will get to everything but Vetric tonight. Okay, so recommendations. Now, for your information, the project files from our prior 3 classes where we did the build a box are also available on my site. And those happen to be the standard Vetric provided the Paradise box 12 years ago as a Vetric monthly project that they pass on to their users. And it's been very popular. There's probably 50 videos on YouTube on how to build a Paradise box. And there's a lot of videos there on how to modify the Paradise box. And that's really next week and 2 weeks later. We're going to focus on how to manipulate the size of this box to satisfy your needs. Now, I know that Bob would like a box that will handle closer to a full sheet of paper, okay? Feasible. We're just going to manipulate the design in Vetric to create larger components and create a bigger box. And I've heard also that there's people that want to build customized boxes for relatives, like grandchildren or others. The designs that we're going to see here pretty soon are just examples of what's feasible. The assumption is that you in some way are going to utilize the Vetric software and modify the design for your purposes for the first box that you build, okay? The original Paradise box, 2011. Was I close? 12 years? Actually, a little more than that. We've cut them in the past with 3/8, a 1/2 inch, and 5/8 inch parts. And there's even a couple that I've given away that were created with 3/4 inch parts. Now, the beauty of this particular design is that it does not require somebody with woodworking skills to put one of these boxes together. There's 50 or somewhere between 50 and 1,000 videos available on YouTube of people building precisely a box with mitered corners, with dovetail corners, with finger joint corners, out of maple and walnut and zebra wood and purple heart. You know, but building a small box like this can be an art project, and people with woodworking skills can can really do a beautiful job and not need a tool like an HD 510 computer control router, okay? But having the router available, it was in Vectric's benefit to get a design in the marketplace where somebody that only has a CNC and no skill can come along and build a box. That's the Paradise box. Their assumption is somebody would go down to Lowe's and pick up some wide pine, cut it into 5 chunks, do 5 separate projects on the CNC, add a bottom to it, and they've got a box, okay? What we've done over the past 4 years, 5 years, is take that basic design and improve it to where it can be done with a better structure, deeper mortises, additional rabbets for additional glue contact, front-back rabbet for the bottom rectangular sides instead of the triangular sides that were in their original design. We do it in one machining step. Bring in a CNC blank, and the machine will cut 5 components and give you a CNC blank cut to how you saw the software emulate it earlier, with tabs holding all of the parts in place. Jack?
I know you and I and Wes know what a rabbit is. And it's very close to Easter.
Thank you. The first one, I made a mistake earlier using, I used miter instead of mortise, and no one caught me. Okay. In woodworking terms, a mortise is a pocket in the wood intended to accept a tenon. Okay, a miter joint is essentially 245 degrees put together. That's going to make an 80-degree edge of a box. And a rabbet is a groove down one edge of a piece of wood that's designed to give you an additional gluing surface when you join it with another piece of wood. Rabbet, mortise, miter. Thank you. Thank you.
Joe, dovetail.
Pardon?
You mentioned dovetail.
I did mention a dovetail, and I hate them. There's some men out there that have the motor skills to create it with a manual saw and put them together. It's simply a piece of wood that's shaped like a dovetail that's inserted into a female that's, again, shaped like a dovetail. And it makes probably one of the strongest joints available, a very strong joint for the edge of a box. No more questions. Okay, so we're really dealing with a Paradise box. This happens to be a picture of the original Paradise box design. This one was cut using the triangular box sides and the traditional Paradise box pattern. A base file to do this box with this design is available, I think, in the at least in the 2023 class project. Let's see. Our modified Paradise box. Here we can resize it to fit the available space on your shelf. Resize it for the available wood that you have, and also to the machine capacity. Now it turns out that this particular box, we have a 15-inch planer in the wood shop. Guess what? 14 1/4 inches. 14 1/4 inches, so that once we get it glued, we can clean it up really well with our planer. That's an example of the design to the piece of wood that you have available. Let's see, reshape, rounded corners. I mentioned earlier that the original Paradise box had a triangular front and back. We've redesigned it now the way we've got straight front and back. We put rounded corners on it, make it a little easier on the hands when you're working the wood. We have a wide number of designs that we've put both on the inner lid, the inside of the lid, and on the outside of the box. If you've seen the box that's the tea box in Marie's restaurant, okay, the tea box in there is a Paradise box that we gave them. Actually, we gave it 2 restaurants ago. We made it for Joe's. Pardon?
There's one in the library too.
Probably, yes. That's one you put there, Wes? Okay. Yeah. I had a couple of boxes up on the top of the shelves in the restaurant also, but they were donated to raffle tables around the country. That's another point for all of the new members. When you read the the procedures manual for the club, we're really not in the commercial business of building product. We build product for our use and to benefit others. Okay, where are we? The inlays are also possible, and let's take a look at some examples. And here again, I'm going to have to
ask you, keep showing us a picture of the boat. Is that where we're going to have our graduation party?
This one is timed. This one is timed where we will end class at 6 o'clock and Marie's closes at 7.
So no. It's worth a try.
Okay, here's a picture. You've seen this one already of an original Paradise. This one is inlaid with walnut. We will talk about inlays on night 4, about an inlay design, okay? Here's a 3D carving. This happens to be a nautical, the compass rose and a ship. There's a lot of 3D carvings here, and I'm going to skip over them real quick. Here again, inlay technique.
No, finger joints.
Here is we did this tool chest on the CNC using finger joints. Here is a customized box. You saw this picture in the class advertisement. Pete made it for a family cribbage tournament. Here's the tea box we put in Joe's. Here's a box that Rosa has on her chest. Okay. Here's again a rose motif. So these are pictures of what we've created in the past, and I present them tonight for your thought about what you want to accomplish here on your box. This is our boat sitting in a lagoon behind the boatyard where we purchased it. This was in 2004. We purchased it, and we kept it until 2015.
What was its name?
Surprise.
Surprise.
It's a surprise that we bought it. Let's say that to build a box, you need about 3.5 foot. Night, Alan. When you compute the board feet, you need about half of that at a minimum, but I would recommend that you purchase a little bit more from the point of view that there could be mistakes. And if you have leftover wood, we'll find somebody that could help you use it in the future. There's a video tonight in homework, I think, of the types of wood. I would imagine we all have a pretty good knowledge of walnut and maple and poplar already. But we're going to mill that wood to the thickness desired. Of course, the recommendation is half an inch thickness as of this particular blank. For those that do want to do resawing, the 3/8 of an inch is possible. Here we're going to use VCarve to modify the basic design that you download to create the size and the decoration of the box that you want. And it's really the class that's going to prep us to be able to make those changes to the software. We can once we have the carving done and the CNC has produced the components, we're going to break them out of the CNC blank, and we'll primarily use the sander to get rid of the tabs that are used to keep the parts stable while everything's being cut. Because we are using round tools when we do cut a pocket, we're going to have rounded corners in that pocket. So you will utilize chisels to clean up and square up those corners. We're going to cut a 1/2 inch medium density fiberboard bottom. Now, we have a stock of 1/2 inch MDF available in the wood shop. So plan to get a piece. If we run out, we'll buy more. We'll make the MDF available. We're going to add a hinge to the project to attach the top, and I have a stock of hinges that I'll be able to hand you a hinge. In fact, you might ask for a hinge before you choose that final design, and then you can tailor the little pocket that's on the back of the box for the size of the hinge that you have. I think I have at least 2 sizes of hinges. And then with the bottom available, we're going to make sure all of the parts fit, dry fit, and then we'll do a class on the glue process before we're over. Now it's ideal we have enough time to go through the overview of the VCarve Pro software. Now this is a PowerPoint slide, so I'm not using live software at this point. But my goal here is to point out major tools that you'll use in the software. And I want to start with the top of the line of the line of menus we have. They're typical for any Microsoft program. File open, file close. Generally, there's going to be a submenu here for everything that you can do within VCarve, but they've made it more easy to use the software by creating icons throughout the window for you to call upon for specific changes to the design. If I look across the top, I see a series of controls that focus on how the the material area of the window is used, and they control how vectors easily snap together. They control whether you're looking at the front or the back of a board for a two-sided project. The information displayed is being displayed in the 2D window, which you see highlighted here. There is a control here that could switch the display to the three-dimensional window, and I'll get to that on the next slide. I have a key control in the upper left of this series of icons. This is commonly called a setup, and there's a couple other names for it, but it's the control where you tell the software the size of the wood that you have available. You tell it the home position on the wood that you want the machine to use. The software and the machine are going to have to match that home position. You tell it the thickness of the material that you're working with, all in what we call the setup. And then there's icons here in the file operations area to open, to look at the folder you want to open. If you look below that, I see an arrow here pointing to names along this edge. This is a 5-layer window under the control of the tabs that are on the left-hand side. The most common use of this window is the design tools, which are being shown at this point. And you have tools here to create vectors, and you can see by the shape of the tool that there are a variety of shapes that you can create. This one, the zigzag here, happens to be the polyline tool, where you can create one line and then extend it to a second line in a different orientation. And then you have a set of tools here to take an existing vector and to transform it in some way. If you look here, this would be to take a rectangle and change it, say, 90 degrees or 180 degrees. And then there's a series of vectors, a series of icons below that you could use to edit a particular vector. And the one that I use most often, by the way, is this one. It allows you to specify the exact location within the workspace that you want this vector to be moved to. Whatever vector is selected could be moved wherever you want it within the workspace. There's a series down here for laying out. Here you can easily duplicate a rectangle to a different size, say a 1/2 inch larger than the rectangle you start with. And then there's a series of modeling tools here, and we'll get into these in night 4 when we're talking about three-dimensional objects. I mentioned the 3D view. There's an icon right here, this icon, that would switch you out of the design mode and into the manufacturing mode, where I have icons on the right side of the screen that, their function in life is to either generate a tool path or to modify a tool path. I start with the top box here, which is an extension of the setup capability. There's some graphics here to give you a reminder of the workpiece that you have and where the home point is of that workpiece, and where the thickness of the workpiece, and whether you're calibrating from the top of the material or whether you're calibrating from the table itself. Now, I should have said whether you're calibrating the Z height or the height of the tool bit to the machine bed or the top of the material. You can see, I think you'll count 15. Am I right there? Is it 15, 6, 11, 14, there's 17. We had 15 in the prior version, we got 17 now. Each one of these, each one of these is a program fine-tuned to a particular type of vector, a particular type of toolpath. Let me back up. For our project box project, we will need to use 3 types of toolpaths. There will be a V-carve toolpath that we'll use for decorations, or maybe cutting a chamfer. A chamfer is nothing but an edge with a particular angle along the side of a piece of wood. I got it. So a V-carve would be used for decorations primarily. A chamfer is a decoration. We would be cutting a pocket. Now, the mortise that I referred to earlier that the sides are going to fit into is simply a pocket. Okay? And there with a pocket, we're interested in telling them the vector that defines the pocket. And then we're interested in telling them the depth of the pocket. And there are a couple other details, but those are the 2 primary ones. And then the third tool path we will need for our project box is the profile tool path. Now, a profile is essentially a cutout. It's a very less intelligent tool path where you just specify a vector, whether it be a box, a circle, or a straight line, and you tell it whether you want to cut on the center of that line or on the outside of that line from start to finish. And the vector is going to cut the tool path is going to cut for a particular depth along that vector. So those are the 3 tool paths that we will need to understand for our project in this class. And we'll go into details of each of those on the 3rd night of class. And you can see below that there is a set of icons that provide tools to manipulate tool paths. Earlier tonight when I showed the simulation of a cut, it was this tool which will trace the tool paths and provide graphics to show you how the finished product is going to look in the software. And then below that are the tool paths that I created for the project boxes that you'll download. Those tool paths will be available to you when you download the project file from the Joe's Boat site. Now we are at the end of the time we have tonight. I won't get into V-carve Pro demonstrations tonight. We'll start with that next week. But I would like to speak to the homework just for a moment or two before we end. I mentioned before to install V-carve Pro to your system. Okay. Obtain wood species. There is a video that's going to talk to the species of woods. And I have here 5 businesses within our neighborhood that have a stock of wood to be purchased. Woodcraft is so close, I always put it at the top of the list. Download the project files from joesboat.com. We spoke to that this evening. I mentioned that either the 1/2 inch or the 3/8 inch file without the side mortise would be the one the recommended. I have 3 videos for you to watch, and this might total an hour, hour and a half. But they're from Vectric Corporation, and this particular speaker from Vectric is very easy to follow. That's one of the great things about the videos. These guys can spend the time, they can build a script up front, and they can precisely step through the script. They offer really more. They offer the ability to truly learn as you follow the videos. Last, there's a rather long, it's about a 20-minute video on the digital design process. Again, this is an actor that speaks very well and is easy to follow. And I have a link here, a link that was broken for Chris earlier, but there's a link here to a Vectric website, which is an online manual for all aspects of the VCarve Pro software. Okay. With that in mind, I can't thank you enough for paying attention tonight. I close by saying there's always going to be optional homework. It'll change from week to week. And it really is there to give you information about the depth of the information that's available on the internet, should you plan to study. Thanks, everybody. Thank you much for. Thank you. Thank you. Thank you.